And now it's time for
a tiny bite
of knowledge.
Hey, Jody, what does precision agriculture and baking have in common?
You need gloves sometimes? I don't know. What do they have in common, Sarah?
Well, when you bake, sometimes you need to use a cookie cutter. When you do precision agriculture, you always need a boundary, which acts like a cookie cutter for where the field operations begin and where they end.
Sarah, that's such a great analogy to describe what a boundary is. Whenever we are doing some sort of field operation or whenever we're trying to make a map, we need to know where that field begins and where that field ends. And that is exactly what a boundary is doing when we create that in our precision ag software.
Absolutely. So let's back up for a second. Usually a boundary is a vector file and some kind of a vector file format. And in ADMS software from GK Technology, we usually use our boundaries in a shapefile format and we work with them in a shapefile format. But why is having an accurate boundary so critical, Jody?
You need to know where exactly in that field. If you're doing a fertilizer application, for instance, if you're making a map about that field, about where you're going to apply it, you want to make sure that A, you're not applying it where you don't have to, right? So if you don't have a boundary that includes the road, your machine isn't going to start spreading the fertilizer outside of that boundary. B, it can help you actually looking at the area that is represented by the boundary of where that field application is going to occur. That can also help you actually predict what inputs you need for that area. So getting that as accurate as possible will help you make an accurate application and help you prepare and plan for that application out in the field. What else might a boundary be important for?
It really is the place where it will shut the equipment off. If you are writing a prescription, that boundary is the edge of where your equipment will shut the equipment off. So for example, if you have a rock pile out in the middle of a field, and that rock pile is really small and you draw a boundary around it, it's going to shut off a whole section. Sometimes that section actually goes into the field a little bit. So you got to think about that. There are actually times where I've got those little tiny rock piles and I actually won't put a boundary around them because I would rather be that tight and that close and make sure that the application is all the way up against that rock pile than shut off a whole section of that boom. So that's an important thing to think about. We also use boundaries when we're making surface drainage maps in ADMS. And when we're thinking about making surface drainage maps, it's a completely different concept than when we're doing nutrient management. We're trying to think about where the water begins and where it ends. So does the water, Jody, at your field, does it start just right at your tillage line on your field? And does it completely end at your tillage line on your field?
No, absolutely not. It flows from someplace else and it flows out of the field on the other end most of the time.
Most of the time. If it doesn't, you probably need a surface drainage map called GK Technology. We can help you with that. But anyway, back to the whole boundary conversation. When you're thinking about water, you need to make sure that you're setting up water from thinking about where it's coming from and where it's going to, so that you can really encompass that whole thing. So you understand what's going on in the watershed, not just within your field, because the water flow across your field is affected by what's going on around it.
Absolutely. So one thing that's really important about actually drawing boundaries in fields is that there's a couple different ways to actually make them. So for example, you might be someone that uses RTK on a gator and you go around your field boundary and collect it that way.
And that's what we call a driven boundary, right, Jody?
Yeah, so that'd be a driven boundary. What you can also do is you can make boundaries in GIS software. And if you're someone that's going to draw a boundary in a GIS software, what's really important is that you don't just use any background to draw onto. You might think, oh, well, if I just open up a Google Earth, that I can just use that background to draw the boundaries. But what's very important is that that background that you're drawing the map onto must be georeferenced. And so for anybody that's familiar with using ADMS, what we always advocate for is downloading a NAIP file, which is part of the National Agriculture Image Program. And what that NAIP image is, it's a really high resolution picture of fields that is also georeferenced. So if you're dropping a pin to draw your boundary, that is going to be very, very, very close to where that location would actually be on planet Earth. So you can draw accurate boundaries with that NAIP image in the background.
So what about CLUs? What's a common land unit?
So what CLUs are, they are used by FSA, USDA to determine contiguous areas of cropped farmland. As a grower, you might get an FSA map that shows what the FSA knows of your farm. And they're like kind of blocky and represent the fields either as they're cropped now or maybe in the past when there was true rows. Basically, it's cropping units. These are all georeferenced, but they're a little bit blocky. They don't exactly get to the specific boundaries and like the corners of your fields. They're pretty rough when it comes to getting at field boundaries, but that's all they need. They just need an estimate.
Common land units are the boundaries that farmers actually certify their acres with the FSA, the Farm Service Agency, annually after planting, so it's a very handy thing to use. But to Jody's point, they're not always accurate for where you actually want to be turning on and shutting off the booms of your applicators and fertilizer spreaders.
They're a great place to start. So if you don't want to draw it by hand, you can pull a CLU in and you can start modifying that boundary to make it a little bit more specific to your field.
There are times and places where I will pull in a CLU, a common land unit boundary, and I'll start there and I'll put that NAIP image on the background just to see how accurate it is. And if I can move vertices just enough so that I get a good boundary out of it, that's great. 99.9% of the time, I'm throwing it out and I'm actually just starting from scratch and drawing so that I have that accurate boundary.
Hey, Sarah, what's a vertice?
Vertice is a point on a shapefile that polygons are made up of lines and points. Point on that line that connects like the corners of the lines to make the polygon. So you can actually move a vertice, thereby changing the shape of the polygon, which is your boundary.
Boundaries are so important. It is one of the bedrock pieces of precision ag and map making. And so the first part of a good precision ag recipe is going to get your cookie cutter out, figure out where on earth that boundary should exist, make it happen, and then proceed from there.
Also, I hope by the time I'm done making a bunch of maps, somebody is baking me a bunch of cookies with cookie cutters. I like gingerbread.
Tune in next time for a tiny bite
Of knowledge from GK Technology,
where we have a map
and an app
for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.